Alright, so this page really throws people off. And the reason it throws people off is because they see these questions that when they first glance they look super easy, but then they're like, okay, let's look at A. Let's see, they give me acceleration, so I'm looking at my formula. So force equals mass times acceleration. They give me this, and then they're looking for mass or force, and then they're like, wait a minute, they don't tell me force. And they don't tell me mass, so I only have one variable. Well, how am I going to solve this with one variable? Well, let's check it out. So, it's actually not that hard. As I said, the first glance, people blows up their mind because you get so trained in I need two variables so I can find the third and da-da-da-da. Well, if we just think about it, it's a piece of cake. So what are we given? We're given acceleration. So remember our formula we just rearranged here. I'll move it down so you can see the other one because I know everybody's pretty confused, but nothing exciting. So acceleration equals force divided by mass, right? Force divided by mass. So if we're looking at, let's bump this up even more. So we're looking at A, this one right here, right? Actually, let's go ahead and do number one so we get it. The acceleration of an object, and we said this in the intro, is blank related to the force upon it and blank related to the mass. So it looks like there's a direct relationship where if you increase the force, that means this will go in more times, which means the acceleration will increase, right? So increase force, you increase acceleration. So that's a direct relationship. Now with mass, it's inversely related. So inversely kind of means oppositely related, right? So in other words, if you increase the mass, will you decrease the acceleration? Because this all of a sudden will not go into this as much, right? So if our force is 20, let's do this. Our force is 20 and our mass is 5. We know 5 goes into 20 how many times? Well, 5, 10, 15, 20, right? 4. So that makes our acceleration 4. But if we double the force to 40, well now all of a sudden 5 goes into 40 how many times? 8, right? So if we double the force, we double the acceleration to 8, right? Now likewise, scratch that, if we double the mass to 10, well now it looks like it goes into this half as many times, right? Because now it only goes in twice. 5 goes into 24 times, but 10 only goes into it twice. So in that case, our acceleration would be cut in half. So, I just made up numbers, but just know that because it is directly related to force and inversely related to mass, it's easy. All we're doing is multiplying or dividing. So let's look at A. A says an object is accelerating at 8 meters per second squared when suddenly has a net force exerted on it increased by a factor of 2. Okay, so let's write it down just so we have something to look at. I'm getting lost. Okay, acceleration is 8 equals force divided by mass. So they're saying what? They increase the force by 2. So the force is doubled. Okay, what do we say about that? If you double the force, you double the acceleration. So you know what that tells me? That tells me I got to look at 8, double the force, that means doubled. I take my acceleration of 8 and I multiply it by 2. 8 times 2, I'm sure you guys already got it by now, 16. Piece of cake, right? Answer is 16. Easy. So let's pick a random one. Let's look at... Okay, it's not random because I'm thinking, right? Let's look at one where the mass increases. Which one does the mass actually increase? So, force. Mass decreases. Okay, let's look at 8. Mass increases. Let me turn this upside down. So, an object is accelerating at a rate of 8. 8 equals, so that's acceleration equals force divided by mass, right? And the force upon the object increases by 4. So this is times 4. and the mass is increased by 2. So this is times 2. Mass is times 2, the force times 2. Okay, what is the new acceleration? So what do we do here? We know that there's a direct relationship. In other words, when it says do this, we do this. So that means 8 times 4. What's 8 times 4? 32, right? So this is the number we're sitting on right now. This isn't the answer, this is the number we're sitting on. Okay, now, remember, if we double the mass, that means the acceleration is inversely related, which means it's cut in half, right? So if we double the mass, that means we divide by 2. So now all of a sudden, we divide this by 2. So we took 8, we multiplied it by 4, but now we got to divide by 2 because we doubled the mass. Which means 32 divided by 2 equals 16. Look at that. Same answer for both. How awesome. Cool. So G16, that's how you do it. Just to kind of go over 3 without giving you the answer. 3 is talking about net force. So if you remember, let's turn this sucker sideways. Net force is just our overall. So if we have a car here, awesome car, and Mr. Barris is pushing it this way at a force of, whatever, 100. And someone else is pushing it this way at a force of 70. Well, you know the net force is going to be to the left, and it's going to be 30. I want to say it's newtons, right? Fix me if I'm wrong, but I want to say the net force is newtons. So that's the overall force. So they're saying, yo, blah, 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 I don't care. Rank these objects in order of acceleration from largest to smallest. Largest to smallest. So first what I would do is I would go through each of these and I would write down right here what their net force is and what direction. If it's, let's make right positive, left negative. Right? So if it's left, just say the net force is negative and then whatever the net force is, right? Alright, so there you go. A couple for this page. Hopefully that helps. You can ask me if you guys got any questions.